So, everybody, welcome. My name is Dick Korf, you heard it already. I'm from Holland, and I'm now about 5 years busy with free energy. And the last time also much more and more about cold fusion, LENR, low energy nuclear reactions. And I will give this presentation together with Gerard Essing. And Gerard Essing I met about 2 months ago during a conference in Zurich, where Andrea Rossi had presentations about his ECAT, energy catalyzer. And we met each other, we became friends, and now doing, trying to do business on the edge of cold fusion. So I will give a small introduction where I am busy with, free energy. And the question is, of course, what is then free energy? And normally I give the explanation, as a fish doesn't know he is swimming in water, we all are not aware that everything around us is energy. And the point is, can we wondering about everything which is around us? And I will start with a few crop circles. I'm sorry, is this one? And especially I am very impressed those crop circles who have a three-dimensional effect. How you see here that's in the flat area, and still you see a double three-dimensional image there. Here you see the same, and you could have the idea that it's possible to go in there. How is that possible? What kind of energy is playing there? Oh, I missed now one. But anyhow, Professor Dr. Klaus Tutte from Germany, I met him different times, and he has made a theory about free energy. And one interesting thing for me is then again that only 5% of matter is visible for us. So 95% isn't visible at all in the universe. And that impresses me every time again. And the question is then, what kind of principles, what kind of effects there are in free energy? And the first one is the permanent magnet technology. I go a little bit fast through it because otherwise Gerard hasn't time enough. Gravity machines. Third, motionless electromagnetic generator, also solid-state generators called. The fourth is water gas, Brown's gas. Fifth, changing magnet fields. And of course, LENR, low-energy nuclear reactions. My first visit when I started with free energy was a visit to Professor Szabo in Budapest on January 2008. Afterwards, I met him again sometimes, but I think that his invention will not become really to reality. It's a very big and giving just heat. This was my visit together with Kees Hoogdijk. He was here. Okay, together with Kees to Ohio, where we met very interesting people, and they have here a pendulum. Here you see this is going, and amazing was that here on this pendulum you only had to give a very few push, and at the same time here a weight of 35 kilos went up. It was really unbelievable. At the moment they have built Oh, that's myself. He is one of the inventors. And they have built water pumps, and they use it also in Haiti, where the earthquake has been. Manual assisted water pump for disaster areas in Haiti. In June 2010, I went to Australia to the Lutech boys, I call them so. And a few months ago, I heard that their invention has been sold to an Arabic sheikh. And I don't know or we ever hear anything about it. This was in Australia. And surprising is then again that they asked so much money for this, while they didn't have a real production-ripe unit. And I can tell a lot about it, but we have to go ahead. Here you see a unit from John Bedini, Lex Velo, a good, I know him very good, has bought it. But the difficulties you get them to make it real working is so difficult. You have to know, you have to have so much knowledge to do this. This is the right one, is Manfred Golubieski. He knows a lot of electrical things, but I heard that until now it doesn't work, still doesn't work. Here I met, I would say, one of the godfathers of free energy, John Bedini. And he presented in, where I was in Idaho 2 years ago, this very big machine, 4.2 meters diameter. And he was telling about this thing that was a wonderful thing, but it only delivered 20 joules per second. And I asked the people, is it true? And why he's talking about joules per second? Because the definition of a joule per second is a watt. So this big unit only produces 20 watts, or 30 watts, no, something like that. So I asked him, John, have I heard it good? 20 joules per second? He said, yes. I said, but that means 20 watts. Yes, yes. And then suddenly he was shaken from, hey, what I have said. Or he even doesn't know the difference between joules per second or watts or what he's talking about. And why in America he is talking about joules per second. I don't understand that. But anyhow, still he is seen as one of the godfathers of free energy. This is somebody I know, Dirk Zandstra, the Gray motor. Here Jan Neuterboom in his own workshop, the Adams motor. This guy I met in Luxembourg, 2010. His whole area is filled with all kinds of different things, gravity and permanent magnet units. Here Yildiz from Turkey. He has given a demonstration in the Technical University in Delft in 2010. And although he was a policeman, he is very inventive and created this machine. And I heard this morning, or yesterday, I heard that he will give a big presentation next year, beginning next year, with the next step he has made. And I understood that he's working together with Japanese people. This is a unit from Peter Svoboda from Austria. And although it was forbidden to make a picture, I still did it because I thought, why not? Yeah. This is a unit from about 12 times 12 centimeters and about 40 centimeters high. On the top, there is a shaft coming out, and that gives some mechanical energy. On the side there are some LEDs working, and at this moment he has now a unit which delivers about 10 watts. Also from this I can tell a lot, but it takes too much time. Yeah, this is also a very interesting invention from Mike Brady. Mike Brady comes from South Africa but lived in Germany. And he is at this moment in jail, damned for fraud. But I know different people who really say that's not true, and they are now working to release him from jail. So that is his invention from 100 and 300 kilowatts will be further developed. These people, Mr. Kepper here in the middle, from Brazil, they showed a unit which gave 4 times more energy, and they increased the efficiency of the existing motor from 20% to 80%, something like that, and they are now working to come to an over unity unit. Yeah, this is also very interesting. There is a Metanita Testatica machine in Switzerland. They don't want to go outside their community, but it's still working for already a long time. And I really hope that one time they will release it to public so that more and more people can use it. This is again about Professor Tutur in Braunschweig, Germany. And he has made a basic for free energy. And that is founded in the fundamental principle of the conversion of zero-point energy of the vacuum. Very interesting guy. I go through. Yeah, cold fusion. Gerard will tell us about that in the next. This is Miran Keshe from Belgium. He's a nuclear engineer from Iran, studied in London. I've met him now 8 times, and is a very, very interested guy. And I have stated here, he's or a fantast, or he's one of the greatest inventors or geniuses of our time. And he has promised that he will show, so he's busy with four different items: medical, transport, energy, special trips in the universe, and I have, of course, most interest in energy. And he will give a presentation and go public, he calls that, the 14th of December. And he will deliver 5,000 units before the end of 2012. So he gets still the benefit of, zeg je dat? Of doubt again, exactly. And I believe still that it will come through. Yeah, also interesting. In April this year, I visited Las Vegas and met there John Reuner, this one guy. And the 14th of December, he will present his unit working on the Orlando Congress in Florida. Hopefully I go to there and see what he has really realized. When I was there, I had to pay $50,000 without I could see a working unit. So I refused, but at the same time, about 18 people all over the world have already paid that, and okay, we'll see. Okay, I give the microphone to Gerard.
Okay, Dick, thank you. Okay, good afternoon, everybody. My name is Gerard Essing. and it's my pleasure to talk to you about LENR, or Low Energy Nuclear Reaction. Hopefully most of you know about it. LENR has this incredible promise. It is this clean energy, which is very powerful, which doesn't give any waste. It uses abundant available materials. You can get it at any place. You don't have to dig deep. And it's cheap. It is the perfect, or maybe near perfect, energy source. Now that sounds too good to be true. Most things that are said too good to be true end up that way. Is that the case for LENR? So that's why we made the title of this presentation, LENR, Is It the Real Deal? And it's a pleasure to share with you this information which is publicly available, but it's moving rapidly. There's a lot of exciting things happening in the LENR field. Before we get started, let me say thanks to Tyler van Houwelingen. He has a website for people who are interested in LENR. It's called, the URL is at the top, lenrproof.com. If you're interested in it, write it down. What Sterling Allen does on a very broad scale, Tyler tries to do specifically for LENR. And he was kind enough to share all this information with us today. And this presentation draws heavily on information from his website. So today, what we're going to talk about, we're going to talk about what is LENR, just to get the facts straight. The question, is it real? Does it exist? You feel the suspense? And can products be expected? We probably wouldn't be asking the third question if the answer to the second question isn't yes, but okay, we'll get to that. Okay, what's LENR? LENR, we know obviously 3 nuclear reactions, the fission, the hot fusion, the ITER projects, and then there's cold fusion, or LENR. And LENR is what we're going to talk about. LENR stands for Low Energy Nuclear Reaction. Low energy because of the low energy that it requires to get started. But it has an output on nuclear scale. So that's obviously the appealing factor of this type of reaction. Now I'm going to read to you a technical definition. We have to cover this, obviously. LENRs are so-called weak interaction neutron capture processes that occur in nanometer or micron scale regions on surfaces of condensed matter. They produce transmutations, elemental transmutations, liberating significant excess energy in the process and without strong radiation or long-lived radioactive waste. Is that clear to everybody? Should we explain a little bit on this, elaborate a little bit on this? To try to explain this, it's all about hydrogen atoms. Hydrogen atoms in certain elements or specific metals are absorbed. And the metal acts like a proper lattice. For people who don't speak English, lattice is like a raster. It's like a proper straight lines, horizontal lines. It's like a filter. And it captures, or the hydrogen that gets captured in the metal, its movement is restricted. And then with an external force added to it, whether that's heat, radio waves, the whole metal structure, the whole lattice gets excited, starts vibrating. Plus you add a source of free electrons to it. And that's how a proton of the hydrogen and an external electron can merge, and you can have a new neutron. And that's the neutron process. Neutrons get captured by other protons, you get the first isotope, and that's how, step by step, this can exist. And we'll get to it because okay, let's repeat this one more time so you're not confused about this. It's a near perfect energy source, potentially. Hydrogen is required, common metals. It's available everywhere in the world. It's low cost, it's powerful, and there's no waste or harmful products. But the problem is, there isn't a single theory that all the scientists agree upon. There's many different ones, but chances are only one is true, and we don't know which one yet. And that limits and hurts the scientific credibility of the field. But at the same time, what you will see, there's many occurrences, and this reaction occurs, and there are quite a few people capable of doing this. So on the one hand, I'm getting ahead a little bit of the story, but on the one hand, you see the reaction, it's there, cannot be denied, but the true scientific explanation is lacking. And that's also why the whole field, we call it LENR, but it's also called CANR, Chemically Assisted Nuclear Reaction, or LANR, Lattice-Assisted Nuclear Reactions, or Controlled Electron Capture Reaction, or simply the Fleiss-Pons effect, or NuFire. And there's probably many more. That's LENR. How did it get started? Well, we've heard the name many times these past 3 days, Fleiss-Pons. Back in '89, there's a whole story about how it came about, but that's not the topic of this presentation. They announced this experiment, and they showed this slide. And what you see here, so what they did an electrolysis of deuterium. And when they did that, for a prolonged period of time, all of a sudden they saw a jump in temperature. And where did this energy came from, was the question. And they thought they'd stumbled upon something that they called nuclear reaction, and they got nicknamed cold fusion. This is the chart that was shown. What you're looking at from here to here is a single day. So over several days, they were doing this electrolysis of deuterium. And all of a sudden, you see here a big spike, jump in temperature, and there was no additional energy as input. So something happened there. The hydrogen got caught in the palladium, and all of a sudden it jumped, and it continued to rise. And then something occurred, and it dropped. And then it started rising again. So that effect was not denied, but very quickly it became cold fusion or illusion. And this was exciting news, obviously, and many laboratories, even the same day it was announced, started reproducing it and couldn't reproduce it. Did they ask Fleiss-Pons exactly the protocol that they followed? No, unfortunately. But the problems of replication were real. Many people, serious scientists, could not replicate the effect. So that obviously hurt the whole reaction. And very quickly it became known as junk science, as you well know. Is that a historic mistake? The jury's out on that. May well be. Other speakers have pointed out that Fleiss-Pons could well be heroes and deserve Nobel Prizes. Indeed, I can imagine. What do we know now? It's not so easy to do this replication. The quality, the purity of the palladium is significant. And there's serious questions whether the palladium that was available at the various US institutions at that time was sufficient to replicate the effect. But also, Michael McCuber of Stanford Research International has done a big paper on it and stated, and has a lot of scientific and statistical evidence suggesting that the loading of deuterium in palladium needs to be in excess of 88%. You need time for that. That time they didn't take to reproduce it. But okay, events happened as they did. It unfolded. But this LENR, once again, represents this exciting potential. Powerful, green, probably safe. There's no radiation, no waste. Near limitless. You need hydrogen, water. You need some nickel or other metals, probably work as well. We can do this anywhere, not just in the developed world. In the underdeveloped world, we can do this as well. It's low cost. We can do it as small as in a battery size. And we can do it as big as to go out on far space exploration missions. Anything in between. And a big equalizer, I heard that term several times mentioned through these days. But the question is, does it exist? Is it a real effect? So despite all the noise and the labeling of cold fusion as being junk science, and other speakers spoke about the dangers being involved in pursuing this cold fusion research, a small group did continue. Are they the true believers? Or I haven't seen that movie yet, it sounds interesting. And where are we today? 30 years on, a lot of progress has been made. Today, there is a growing list of very credible people, scientists, institutions of good reputation that have many times demonstrated this LENR effect, or this anomalous heat, as you want to call it. In fact, the first statement is not just a growing list of credible people that affirm that it exists, you can turn it around. It's a growing list of very credible people that cannot say that it does not exist. Both statements are true. And there are many peer-reviewed LENR articles. There are thousands by now reported replications of this over-unity, of this excess heat. And recently, and that's why this seems to be taking off and accelerating in the last couple of months, or certainly this year, and even public demonstrations have occurred. At MIT, in January of this year, Professor Peter Hagelstein started a course, Cold Fusion 101. With a group of students, he built a LENR device. Mitchell Schwartz of Jet Energy helped him, and they put it on film, you can see it on YouTube, and he started operating it. They built it together, they started it up, it ran continuously past the middle of June, non-stop, producing over-unity. And then we have Professor Celani, don't know if I pronounce his name right, Francesco Celani from Italy, from the Italian Nuclear Institute. He has put out, brave man, a demonstration, a piece of what he is working on in his laboratory, and he's taken it to the scientific conference of National Instruments. There's a week-long scientific conference called the National Instruments Week. From Italy, he flew in and he brought this cell with him. Turned it on in a public area, not a very ideal lab environment, just to demonstrate to a big scientific group that this over-unity can be produced. And then he took it also with him. The ICCF stands for the International Conference of Cold Fusion. And the 17th version was this year in August in Korea. And he took it there and he showed it, and all his colleagues confirmed what he did. And we'll get back to that because you have a wonderful piece of homework that was lying on your chair. And we'll get back to it in a moment. So I do not want to bore you with a whole list of credible names, but people that heard the talk this morning, and the name was mentioned, Dennis Bushnell, Chief Scientist of NASA. On their website, on NASA's website, Dr. Bushnell clearly states about the type of research they've done at NASA, the patents that they have applied for, and that they are convinced that LENR is the type of technology that will help them into the future. But you also see Nobel Prize winners from the UK, Dr. Brian Josephson. Michael McCuber is probably one of the most known in the US respected scientist at Stanford Research. Edmund Storms, his name was mentioned. Peter Hakelstein at MIT, Professor Piantelli, the palladium expert, and a long list. I will not bore you with all the names. If you go to the website, LENR Proof, you can see them, and there's more of them. Not only is it these scientists that are getting convinced and showing all these demonstrations. As you can see, several scientists have worked with the European Union, and as of July of this year, for the very first time, LENR as a technology is recognized, and as they stated, the ENEA, the Italian Nuclear Research, Stanford Research, and the National Research Laboratories in the US have conducted, at their request, a lot of tests. And the main task was to demonstrate the existence of this excess heat. This target was clearly achieved, and the existence of this Fleischmann-Pons effect, if you like, is no longer in doubt. A big statement. So they recommended, so the existence of the effect is no longer in doubt. LENR has unlimited, sustainable future energy technology potential. And as a result, LENR is now specifically recognized, and funds are available from their Framework 7 research program, the huge R&D source of funds from the European Communion. It can now be applied for LENR projects. NASA. They've shown strong support. 2 patents. They've been studying it for several years, and several persons publicly confirm this effect. We talked about Dr. Bushnell, but also his colleague, I'm not even going to attempt to pronounce his name, says, LENR, is there a better way to do nuclear reactions? And these aren't vague statements, they're very clear statements. Then we have the US Space and Naval Warfare Systems Command, SPAWAR. They see the potential, obviously, for military applications, and even some documents that got declassified, they clearly state that already they confirm that LENR is real. And what's interesting, they had a presentation that was made available, and that has the nice story. 20 years of LENR, it's been hiding in plain sight. It's kind of interesting that it's they took that name. So another website, if you're interested in this field and if you want to continue following the progress, thanks to Jed Rodwell, he has this fantastic digital library, if you like. It's called lenr/canar.org. All the major papers, whether that's presentations, whether that's peer-reviewed articles, and he tries to collect everything and from a single source try to make that available. So if you're doing any type of research on it, it's a great resource. That's all public statements. But there's nothing like seeing a real reactor working. So what you see here is a list of several, this is by no means an exclusive list and complete, but some of you who follow the field may recognize some of it. MIT at the top, this was the Peter Hakelstein's Cold Fusion 101 course. Is he going to do it again? I don't know, but it's certainly be interesting. Professor Celani with his reactors took a lot of courage probably with this controversy in this field to just bring an example from your lab taking it not at all to an ideal scientific environment, turning it on, and it works. Independently measured, and not your own instruments, somebody else's measurements equipment, demonstrating how this can work. And then we have in Italy, even a high school that's involved in this. But we cannot look at this without mentioning Andrea Rossi. Andrea Rossi, there's a lot to be said. People find him controversial, they love him, they hate him. But the whole field needs needs to thank him, because he has done and come out with efficiencies, with temperatures that are so big they cannot be ignored, and they get a lot of attention. What's lacking is proper scientific independent validation, and until that time this gray area will remain. But he is onto something, undeniably. He produces, with these simple materials, he produces reactions in excess of 1,000 degrees. They're on a nuclear scale. There's no other explanation. His measurements might be off. He can be off by a factor of 10, and it's still a very important aspect. So a lot of, and he is very public. He shares a lot of information. He's missed a lot of deadlines too, and that's part of the controversy. But he has progressed and helped draw attention to this whole field of LENR, that irrespective of what happens, we owe a lot of gratitude to him for that. Okay, this is your homework that you found at your chair. Martin Fleischmann, we don't need to explain who he is anymore, unfortunately passed away this past August 3rd, right before the International Cold Fusion Conference in Korea. People there who've been working in this field, they feel obviously a strong connection, and it's a shame that he doesn't get to live and be part of the excitement that's now in his field and the progress that's now being made across the globe. So what they decided is they got together, the scientists, and they said, we're going to organize something to help draw more attention to this field and see if we cannot break out into mainstream area. So they went around and they agreed, and Celani, Professor Celani from Italy, was kind enough. He said, I make available my technology. I have this relatively simple cell. I don't want to underplay it, but it's not, you'll see it in a second. He said, I will make it available. I'll make all my protocols available, all my instruments, and anybody who is interested in it, who doesn't believe it and wants to experience it themselves, spread the word. Any institution, any company, anybody who's serious about this can get and purchase an LENR reactor. At cost, this is a non-profit exercise. A group of young people with good backgrounds. You can see it on the website, quantumheat.org. As we speak, I get excited about this. Right now, they are loading the hydrogen in the wire, and they're seeing the first effects of excess heat. These are guys who've never done this before, not worked in labs, and they're putting the kit together just on the instructions that Celani gave them. It's an open source project. Check it out on the website. You can follow all the steps that they're making. quantumorg.heat. This is what an LENR reactor may look like. Here you see a quartz tube. In it, there's control wire, and there's a metal wire, ISO 10 in this case, which is nickel and copper mainly wire. There's a feed-in for hydrogen gas. They put it under a little bit of pressure, not much. They let it soak, if you like. The hydrogen gets absorbed into these metals, and they excite the whole wire just with heat. It gets measured. There's measurement equipment that goes along with it. First they calibrate it, and then you see the proper measurements. Exciting stuff. You and I, we can all produce excess heat as of now. Let me say that again. You and I, as of now, we can all produce excess heat. Thank you, Quantum Org. Thank you, Professor Celani. But it's doable. So anybody who has any doubt, is this reaction real? You don't have to. You either believe this, or you get a unit yourself and convince yourself. And this is not for playing. This is serious. Not sure if it's public information. Imperial College in the UK, they're going to receive a unit soon, and they're going to start a project with that. Hopefully other institutions will get involved, and companies can get involved. Anybody who's serious. It's never been easier to get your hands on one of these. This is not for commercial purposes, obviously. This is for R&D purposes only. Okay, so where are we at? Today, we have moved on from Fleischmann-Pons, which was the electrochemical loading of deuterium in palladium, to gas loading of deuterium in palladium, and the third type of reactors are gas loading of the hydrogen protons in some kind of metal, mostly nickel. So, the answer to the question, is it real? Does it exist? Without a doubt, yes. Can we expect products? Well, maybe this first R&D type of reactor is the first product. But there's a long road ahead. What you will see on the lenarproof.com website, you'll see this chart. You see the progress that's been made over the last couple of years, where we are now, and let's just, we don't even have to look specifically at the numbers, but increasing capacities are being claimed, increasing efficiencies are being claimed, and Andrea Rossi, Defcalion, and Brillion are the three companies that put out the highest claims at the moment. You can't order products there yet, but they're seeing a lot of progress on their technology. There's a list of LENR companies that you can research and find that they are active in this field. Andrea Rossi is at the top. Brillion, Defcalion, you have nickel hydrogen energy. They made a subdivision metal energy, jet energy. Well, you can read the list. And is this exclusive? Probably not. This is what's available. There's probably a lot of companies who don't want to raise any awareness about this, that they're busy and they're there too. Who knows? But I hope you get a sense for how much progress has been made. This has moved way beyond, oh, wouldn't it be nice? There is a lot of solid people, solid demonstrations, not once, not twice, thousands of times. This is real. So we've moved into a process where it's not a question of if it's real, we're moving into an engineering phase where we're trying to get control over this reaction. You need all kinds of control, let's say, in order to make a product. You need to be able to reproduce it every time you turn it on. It needs to occur for it to be a useful product. You need to be able to have an on and off switch. When you press on, it needs to start, and when you press off, it needs to go off. It needs to be sustainable, scalable, reliable. Various companies at different stages, they make claims towards this. I'm talking about public information here. I don't know how far they all are, but they are making progress, and they are more and more getting control over this. We are at an early stage, obviously, but it's not going to go away. There is a lot of good news coming real soon. And there's talk about, do we need to fully understand, from a scientific point of view, at a detailed level, the theory of what this reaction is all about? Or the other approach is, let's develop the products that meet all of these criteria, that are going on off, that you can scale up, ramp down on demand, and that you make practical products of, that are safe, that all these good things, without understanding the full theory. Chances are, the companies that are involved, and when you talk to them, they will say, well, we're less interested in understanding exactly what it is. We want to be able to control it, make workable products, and meet all these reproducible on-off sustainability, scalability type of criteria. So, anybody's guess, we could have made a game out of this. What do you think? We don't know in the end of the day. And again, this website publishes these numbers. There's a 33% chance 12 months from now we'll see the first products. Is Tyler right? We don't know. In a year we'll know. And that percentage goes up with time. And I guess the exact percentage and the exact time is not so important. I guess the message we want to give is it's near. It's very near. Maybe a lot nearer than you all think. So, in conclusion, LENR is a very promising technology that you can get excited about. I do. It's environmentally, from an environmental perspective, from a social perspective, from an economic perspective. It has great promise. We can switch out coal-fired installations in power stations and replace them with LENRs. We can do it on a small scale, and we can do it on a big scale. And it is near. It's not this year. Maybe it begins next year, but it is coming soon. The proof of the technology, it exists. First prototypes can be seen. You can order them. And did I mention that it says that you are very kindly invited to make a small donation to them to help progress the work? Spread the word, please. And if you can, go to the website and make a small donation. And I'll repeat that in a moment. There's many challenges that remain, clearly. Nobody's underestimating this. But the promise of what it can deliver is so appealing that fortunately there's a big increase in resources being made available, but that can be accelerated. So let me conclude by asking you, suggesting, get involved. No matter what you do, get involved. It's worth it. Have no doubt. Whether that's in R&D, whether that's in finance, whether that's in business, whether you're in politics or government, in policy, get involved. It's worth it. So, many thanks for this presentation to Leonard Proof, newenergytimes.com, Leonard Kenner, for all the information that's available. And again, a call to you. If you can find it, go to quantumheat.org and help them out in making this LENR technology available to as many people as they want. Thank you very much.